In Python, how do you automatically assign employees to shifts and generate a feasible schedule? In such a schedule, no employee has 2 shifts at the same time, or too little time between shifts. Also, each shift is assigned to an employee with the right skills. And that's just the tip of the iceberg of constraints. Additionally, how do you optimize that schedule for cost reduction, service quality, and employee happiness? With Timefold. Either build your own model on the open source solver, or use the enterprise model for employee scheduling. Let's start the open source way. Clone the Timefold Quick Start repository and go to the directory python/employee scheduling. Follow the instructions in the README, and this will pip install Timefold from PyPy. Run the quick start and open the demo application in your browser. So I start the application, and now I can go to my browser to take a look at it. So in this case, we need to assign these shifts to employees. As you can see, we have a number of shifts here. They're all unassigned. We also have a number of employees, as you can see, like Pat Lee, Chad King, and so forth, who can be assigned to these shifts. Some of these employees don't want to work on certain days. For example, Chad cannot work on the 8th of July, Monday the 8th of July, so that's red. And Elsa Green does not like to work on Thursday the 11th of July, so that's an undesired assignment. On certain days, they actually prefer to work. Like, for example, Bat Lee wants to work on Friday the 12th of July. Now, when we actually go back here and we click the Solve button, it will now call our Python code and it starts assigning these shifts to these employees. And if you can see, it's actually gotten its first solution here. Let's assign these, all of these shifts to all of the employees. We'll stop that for a minute. And the first thing you can notice is that all the shifts are assigned. And the second thing is, if you actually go look at it per employee, what you can see is that all of the that people are not assigned when they cannot work. So for example, Chad King is unavailable on the 8th of July, and of course he's not getting a shift on that date. On other dates, like for example, Friday the 12th here, Pat Lee wants to work, so of course we try to give her a shift. And on top of that, a lot of other constraints have been taken into account. For example, no 2 shifts at the same time for the same employee, or and enough time, at least 10 hours between 2 shifts for the same employee. So you can see, for example, here there's enough time between those 2 shifts. Now, let's take a look at the code behind that. So if we jump into the code, what you'll see if we go into the Python example of employee scheduling, and we look into the sources, you'll find a number of Python files here. We've split it up just to make it a bit more manageable. Most of this is dealing with exposing the REST API and bringing that to the UI. But there's a few files that you really want to take a look at, and there's actually 2 of these, and this is the demo and the constraints file, so, the domain and the constraints file. So let's take a look at the domain file. In the domain file, we actually specify our domain classes. So we specify a class of employee, and that has a name, which is a string, and that has a number of skills, which is a set of strings. And we make sure that these skills are automatically filled in. This is mostly for testing and for JSON purposes. So it's filled in empty by default. And the name is actually annotated with a planning ID, which is useful for some of the things that Timefold can do for you. Each employee also has a number of unavailable dates, undesired dates, and the desired dates. Those were those red, orange, and green squares you saw earlier. And then, of course, we have our shift, and each shift needs to be assigned to an employee. So each shift will be assigned to an employee, as you can see here. But each shift has a start date and an end date time. All right. Some of these might actually have a location and a required skill. So if they have a required skill, then of course that shift needs to be assigned to an employee who has that skill. And we'll take a look at that constraint in a minute. So how do we let Timefold know that it can actually pick for each of these shifts which employee to choose from, And the way it does that is we say, okay, this shift is actually a planning entity. That means that something changes during solving when we click that solve button. And more specifically, we annotate the employee field with a planning variable annotation, which means that Timefold knows I can actually fill in that employee based upon the list of employees that I have. How do you give it a list of employees? Well, that's the employee schedule, which is basically just the list of employees, the list of shifts, and then a few other fields, which gets automatically filled in by Timefold as we're solving it. Now that we have that, we need some demo data, of course. So when we go into the demo data file, what you will see here is we generate some demo data with a number of locations, a number of employees, and a number of shifts. I will not go into this here right now, but you can, of course, change this, create your own data set, or even load it from a JSON file and send it in. So the next thing is, of course, the constraints. So like I said earlier, we have a number of constraints, and one of them is that an employee can only do one shift at a specific time. So we don't want to have overlapping shifts. So how is that implemented? Well, we basically just say, okay, we write this in a way such that the solver can actually speed this up. And so we have to write this in a functional way so the solver can do something called incremental score calculation to make this faster. And the way it does that is you basically say, okay, select me every unique pair of shifts. So get me 2 shifts that are not the same, right? And then I'm going to check if these shifts actually have the same employee. So we're going to just check if they're assigned to the same employee. We're also going to check if they're overlapping. That means that when we look at the start and end of those 2 shifts, that they're overlapping one way or the other, doesn't really matter. And when that's the case, then we have an employee who has to be in 2 places at the same time. So that's obviously something we want to penalize, something we don't want, and we penalize that as a hard constraint. And that's an overlapping shift constraint. Similarly, we have a whole bunch of other constraints, a number of hard and soft constraints, as you can see here. Let me just pick one more hard constraint from the list. We also have the required skill constraint. So when we look at the required skill constraint, what we do is we say, okay, for every shift, I want to filter out all of the shifts where the required skill of that shift is not in the list of skills that employee has. And if that's the case, again, we break a hard constraint and we don't want it. There's also soft constraints. Like in this case, when we assign somebody to a day that they want to work, let's just go into that constraint for a minute. What you can see here is that for every shift where the starting date of that shift is in the desired dates of that employee, and there's a bit of logic there. What happens when the shift ends at midnight and stuff like that. So you actually need some complex date calculation there to get that exactly right in many cases. So you can do that too, of course, because you can just reuse your date calculation from Python in these constraints at runtime. Really powerful stuff. And then when that happens, we will actually reward that, not penalize it. We want more of that. We will maximize that. And as a soft constraint, and of course we can weight this differently, but in this case it's just one soft. And we will also multiply it by the number of minutes of that shift duration length. So the longer the shift is, the more we actually reward that being assigned to a day that employee wants to work. So that's one of the soft constraints. Now you can add any other constraints you want quite easily, but you also need to test them, of course, because if it isn't tested, it doesn't work. Just to show you that, let me open the project window. And in here, what you see is in the tests, we actually have for each of these constraints a test. So in here, as you can see, for the required skill constraint, we set up an employee called Amy. And we're going to verify that for that particular constraint and that constraint only, if we create a shift where the required skill is, in this case, skilled, but Amy does not have that skills, that we actually penalize by 1. Right? In this way, you can write all of your constraints. And like I said, this example actually also exposes it as a REST API. So you can actually integrate that quite easily into your architecture. If you're stuck, post a clear question on Stack Overflow, tag it as Timefold. Together with the community, we regularly answer those questions. Instead of building your own model, you can also use the enterprise model with over 50 constraints to choose from. Post your problem to the REST API and retrieve it when it's solved. For more information on that, contact us. That's how you automate and optimize scheduling employees to shifts in Python.